Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about the conversion of other number systems to decimal number system of base 10, such as converting binary, octa, and hexadecimal number system to base 10. So let's begin. So the first one we're going to look at is going to be binary number system, which is base 2. We're going to convert to decimal number system of base 10. Also, we're going to be looking at octa number system, which is base 8. We're going to convert it to decimal number system of base 10. And finally, we'll look at hexadecimal number system of base 16. We're going to convert it to decimal number system of base 10. Now, take note, this is the simple formula. So all we're going to do is that we're going to carry out the summation of the digits multiplied by the radix. The radix is the base value raised to the power of the place value, which is denoted as PV. For octa number system, we're going to do the same thing. It's going to be the summation of the digit multiplied by the radix, which is 8, raised to the power of the place value. Also, we're going to do the same thing for hexadecimal number system. We're going to use the same formula, which is the summation of the digits multiplied by the radix, which is also known as the base value, and then raised to the power of the place value. So it's important that you understand that PV, which is PV that we have here, is known as the place value. So PV denotes the place value. Now let's take an example. So let's consider this example that says 1100 base 2 equal to x base 10, find x. So let's convert this binary number system to decimal number system of base 10. So all we need to do at first is to identify what kind of value is this. This is a whole value without a decimal point. So what we're going to do is that we're going to denote the place value. So we're going to assign the place value on each of these digits. Now we're going to start from the right to the left, numbering from the least value to the highest value. Now we're going to begin from the right to the left. So 0 is going to have 0, 1, 2, 3. So this is how you number your place value. You're going to start from the right to the left. And as you number, you're going to begin with the lowest digits, starting from 0 to the highest as it progresses. Once you have assigned the place value to this digit, the next thing we need to do is to start multiplying. So we say we take 1, which is this one, multiply by the radix, the base value, which is 2, raised to the power of the place value, which is the PV. So that's how we got this. Plus, because it's a total summation, we take the next value, which is 1, multiply by 2, which is the base value. That's what we have here. Raised to the power of the place value, which is 2. That's how we got this. Then for this one, we say 0 multiply by 2, raised to the power of the place value 1. That's how we got this. 0 multiplied by 2 raised to the power of the place value. Then for the final 0, we say 0 multiplied by 2 raised to the power of the place value, which is 0. So we have 0 multiplied by 2 raised to the power of 0. Alright, so we further simplify the first expression. We have 1 multiplied by 8. So 2 raised to the power 3 is 8. So plus 1 multiplied by 2 raised to the power 2 is going to give us 4. Plus 0 multiplied by 2 raised to the power 1 is going to be 0. 0 multiplied by 2 raised to the power 0 is going to be 0. So anything multiplied by 0 is going to give us 0. So all we need to do is to, when you multiply this, you're going to have 8. Multiply 1 by 8, you're going to have 8. 1 by 4, you're going to have 4. And then when you sum this together, 8 plus 4, we're going to have 12. So this is how simple it is. So this is going to be 12 base 10. So whichever way you have written it, it's correct. So when you write the value this way, 12, it signifies that this is base 10. This is decimal number system. If you want to include the base value, which is 10, you can as well also include it. Both ways are acceptable. Right, so both ways are acceptable. Any of this way is acceptable. So let's go to a second example that has a decimal point. Alright, so let's consider this example with a decimal point. It says 1100.01 base 2 equal to x base 10. Find x. So the first thing we're going to do is to assign the place value on this digit. So in this case, this digit includes decimal point. So what we're going to do is this: we're going to consider the values, the digit before the point, and then we're going to treat this digit before the point as a whole. So at this point, we're going to number from right to left, starting from the least value, which is 0, just like we did in the previous example. So we're going to have 0, 1, 2, 3. The next part is to consider the values, the digit after the decimal point. So in this case, we're going to be assigning the place value starting from left to right. So in this case, we're going to begin with -1 and progress to -2. So in this case, we're going to have 0 is going to be, the place value for 0 is going to be -1. Then the place value for 1 is going to be -2. So this is how you assign your place value for a digit that includes decimal points. So we need to start simplifying this. So all we need to do at first, we need to say 1 multiplied by the base value raised to the power of the place value, which is 3. That is how we got this. Plus, because it's a total summation, we say 1 multiplied by the base value, which is 2, raised to the power of 2. That's how we got this. So the next one is 0. We say 0 multiplied by 2 raised to the power of 1. That's how we got this. The next is going to be 0. So we say 0 multiplied by 2 raised to the power of 0. That's how we got this. 0 multiplied by 2 raised to the power of 0. Then we say plus. The next value is 0. So we say 0 multiplied by 2 raised to the power of -1. So you have 0 multiplied by 2 raised to the power of -1 plus. The next value is 1. So we say 1 multiplied by 2 raised to the power of -2. So we got this: 1 multiplied by 2 raised to the power of -2. So let's simplify this further. We say 1 multiplied by 8, 2 raised to the power 3 is going to give us 8, plus 1 multiplied by 4, which is 2 raised to the power 2, is going to give us 4. So that's how we're able to simplify this into this, and simplify this into this. So anything multiplied by 0 is going to give us 0. So this is going to give us 0, this is going to give us 0, and this is also going to give us 0. So we say plus 1 multiplied by this equation can easily be represented as this. So in order for we to get rid of the minus sign, we have to introduce a fraction. So we say 1 multiplied by 1 over 2 raised to the power of 2. Right. So to further simplify this line of expression, we say 1 multiplied by 8, we have 8, plus 1 multiplied by 4, we have 4, plus all of this is going to be eliminated. Then we say 1 multiplied by 1 over 2 raised to the power 2. So 2 raised to the power 2 is going to give us 4. So we're going to have 1 over 4. So 2 raised to the power 2 will give us this 4. So we have to sum up these two values. That gives us 12 plus 1 over 4. The same value we have here. Now we have to convert this fraction to decimal value. So we say 12 plus 1 over 4 is going to give us 0.25. So when you sum up 12 plus 0.25, so once you sum up 12 and 0.25, you're going to get 12.25 base 10. So this is how simple it is to convert a binary number system with decimal places to decimal number system of base 10. So the next example we're going to be looking at is to convert octal number system to decimal number system of base 10. So let's look at this. Previously we looked at how to convert binary to base 10, and in this case we're looking at how to convert octal number system to base 10. So the example says 1 2 base 8 equal to x base 10, find x. So the first thing you need to do is to assign the place value. Now, when you want to assign the place value for a whole number that doesn't contain decimal points, you start from right to left. So you start from right to left, numbering with the least value starting from 0. So we're going to begin from 0 and then 1. So in this case, we're going to express this out. So we're going to say 1 multiplied by 8 raised to the power of the place value, which is 1. So that's why we got 1 times 8 raised to the power 1, plus the next value, the next digit is 2. Say 2 multiplied by 8 raised to the power of 0, which is the place value. That is how we got 2 multiplied by 8 raised to the power of 0. Now this is equal to, when you simplify this out, you're going to have 8. 1 multiplied by 8 raised to the power 1 is something as 8. So once you have anything raised to the power 0 is 1. So you say 2 multiplied by 8 raised to the power 0, this is going to give us 1, because anything raised to the power 0 is going to give us 1. So 2 multiplied by 1, we're going to get 2. So at this point, we're going to get 8 plus 2, which is going to give us 10. So therefore, we can say that 1 2 base 8 is equals to 10 base 10. So this is how simple it is to convert octal number system to decimal number system of base 10. Alright, so let's take a second example that includes a decimal point. So in this case, we have 12.10 base 8 equal to x base 10. Find x. Now, like I said, this digit contains decimal point. It means we're going to treat it in a different way compared to the first example. Alright, so what we're going to do is we're going to start assigning the place value. So we are going to consider the digit before the decimal point and assign the place value starting from right to left with the least value. So we're going to begin from 2, so it's going to be 0 1. Then for the digit after the decimal point, we're going to number from left to right. So we're going to begin from -1 -2. So that is how we are able to assign this place value to these digits. Alright, so you can see for 1 you have -1 as a place value. For 0 you have -2 as a place value. So the next thing we need to do is to express this out. So we're going to say 1 multiplied by 8 raised to the power of this 1, which is the place value. That's how we got this. 1 multiplied by 8 raised to the power 1, plus the next digit is 2. So we say 2 multiplied by 8 raised to the power of the place value, which is 0. That's how we got this. 2 multiplied by 8 raised to the power 0, plus the next value is 1. So we say 1 multiplied by 8 raised to the power of -1, which is the place value. That is how we got 1 multiplied by 8 raised to the power of -1, plus the next value is 0. We say 0 multiplied by 8 raised to the power of the place value, which is -2. That's how we got 0 multiplied by 8 raised to the power of -2. So we need to simplify this further. So 8 raised to the power of 1 is going to give us 8. So 8 multiplied by 1, we're going to get 8. Plus 2 multiplied by 8 raised to the power 0. Anything raised to the power 0 is going to be 1. So 1 multiplied by 2, we're going to get 2. Plus, now we have 1 multiplied by 8 raised to the power of 1. So we need to convert this to fraction. So all we need to do is to say 1 multiplied by 1 over 8. It's something like saying 1 over 8 raised to the power of 1. Alright, so we're going to get this, converting this to fraction, it's going to give us this. So it's going to be 1 over 8, okay, plus 0. This is going to give us this 0. Alright, so let's go further in simplifying this. 8 plus 2, we say 8 plus 2 plus 1 divided by 8, you're going to have 0.125. So we need to convert this to decimal. We need to convert this fraction to decimal. Always have that at the back of your mind, that you always need to convert the fractions to decimal. Always convert the fractions to decimal. Now you have 8 plus 2, which will be 10, plus 0.125, which is this. And then when you sum this together, you're going to get 10.125 base 10. So this is how simple it is to convert octal number system with decimal point to decimal number system of base 10. So the next example is to consider the hexadecimal number system conversion to decimal number system of base 10. So let's look at this example. So this example says that 1f base 16 equal to x base 10, find x. Now you may be wondering, why do we have x? What is the business of f as an alphabet in this expression? Now let me take you to a brief introduction to hexadecimal number system. I have done a video on hexadecimal number system, so do well to check my previous video on hexadecimal number system. But I'm going to explain to you a little intro to this subject so that you can follow along as I explain this example to you. So hexadecimal number system consists of both digit and alphabet. Now let me take you through the digit and alphabet that we have in hexadecimal number system. We have the digit runs from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have A, which is equal to 10. You have B, which is equal to 11. You have C, which is equals to 12. You have D, which is equals to 13. You have E, which is equal to 14. And then you have F, which is equal to 15. So let's go back to the example that says 1f base 16 equal to x base 10, find x. Now the first thing we need to do is to assign the place value. Since this is a whole digit without decimal point, then it means we have to start from right to left, numbering with the least value, which is 0. So we start by assigning the place value to f as 0, and then the next one is 1. So let's express this out. So let's carry out the expression. So we see 1 multiplied by 16 raised to the power of the place value. So that's how we got this. 1 multiplied by 16 raised to the power of the place value, which is 1. Plus f multiplied by 16 raised to the power of the place value, which is 0. That's how we got f multiplied by 16 raised to the power of 0, which is the place value. Now if you express this out, 1 multiplied by 16 raised to the power 1 is going to be 16, because 16 raised to the power 1 is 16. 16 times 1 is 16. You're going to get 16. Now in this case, when you multiply f multiplied by 16 raised to the power 0, you're going to get f, because anything raised to the power 0 is 1. So 16 raised to the power 0 is 1. 1 multiplied by f, you're going to get f. So now what we're left is we need to sum up 16 and f together. So it's going to be 16 plus f. So in that case, since we know f is 15, so f is 15, so therefore we're going to say 16 plus 15, it's going to give us 31. Alright, so we can say that 1f base 16 is equal to 31 base 10. So this is how simple it is to convert hexadecimal number system to decimal number system of base 10. So this is the end of this topic. So pay close attention to the subsequent videos in this channel. Alright then, enjoy this video. Bye.